So what makes our ability to produce and understand speech so unique in the animal kingdom? So as usual for topics like this, it's useful to compare with very similar creatures that lack this ability. Both chimpanzees and bonobos do possess the physical components necessary to generate speech. So why don't they? Most animals, it turns out, can't actually learn to make new sounds at all. The exceptions, of course, being things like birds, for example, songbirds, parrots. But we have trained some apes to produce gestural language, such as sign language. And macaques, if I'm saying that correctly, are able to produce different calls for different types of predators that come into their area, and they're able to understand the difference between those different calls. They're so similar to us, one has to ask the question, why can't they do the same things we do? And it's because our brains are fundamentally different from theirs. As I said in the first video of this series, our brains are wired for communication. Scientists found that if you damage an area of the brain called the Wernicki Area, which I am confident that I mispronounced, you are no longer able to understand speech. This region of the brain, while more sophisticated in humans, is actually quite structurally similar to that in macaques. A different region of the brain in the temporal lobe, called Broca's area, again, when damaged, prevents a subject being able to produce speech. Now, we have this region in our brains, but chimpanzees and bonobos and macaques do not, so they're able to produce those kinds of sounds without this region of the brain that we so heavily depend on for our speech. We should try very hard not to think about what damaging a region of the brain means either for humans or for apes that we experimented on, or I'd just like to believe we happened across one that was already damaged from some natural cause, but I know that's not the case. Scientists have identified a gene called the FOXP2 gene. Now, apes, monkeys have this. Other animals have it as well. The difference is a specific kind of mutation that is specific to humans in this gene. So to the best of our knowledge, this one gene is the entire difference between the speech areas of our brains and other animals' brains. Another major difference between our ability to speak and apes, for example, is that we tend to ask questions. We understand the concept that someone else might have a concept in their mind, or an idea, or a knowledge that we don't. Apes, like those who have been trained to speak with sign language, do not ask questions. There's a famous experiment where children at different stages of development don't understand that their perspective is different from someone else's. But past a certain point of their development, they acquire this ability, and we retain it for the rest of our lives. Apes never do. So to answer the question, why do we speak when monkeys can't, the real answer is not as simplistic as, well, we're smarter than them. No, our brains are engineered specifically to be able to do this at a deep level. This is a fundamental part of how we conceptualize the world, is through our language, because we want to be able to communicate our experiences to other members of our species. And sometimes cats or dogs. We try to communicate with everything. We talk to inanimate objects. It's very deeply ingrained in our consciousness and our way of interacting with the world. So there are some interesting differences between us and our closest genetic relatives that make us, us. I've got links in the description for most of what I'm talking about today, so you can go on your own deep dive and find out even more interesting facts about this. Thanks for stopping by. If you have an interesting idea you'd like me to discuss in a future video, please leave a comment down below.